Hey folks, welcome to my channel, Number Pen. So we have the problem on our screen. Find the points of discontinuity of f of x where f of x equals sine x for 0 lesser than or equal to x lesser than or equal to pi by 4, and the function takes a value cos x for pi by 4 lesser than x lesser than pi by 2, right? So the two parts to this particular problem, right? So one is, you know, we do not have to really worry about the interval x greater than or equal to pi by 2, right? Because we've not been given that information. What is f of x? And it could be that f of x is not defined at all. And similarly, for x lesser than 0, this function f of x is something that we don't have to really be concerned about, right? So let's define the interval where we'll have to examine the continuity. So that is the first part, right? So interval where the continuity is to be examined, right? And what is that interval? The interval where continuity is to be examined, right? And what is that interval? That interval is x belonging to, this is where you'll have to observe this a bit closely. It includes 0, but it does not include my pi by 2, right? So let's call it like this. It includes my 0, but it does not include my pi by 2. And so this is one part of the problem, right? We'll have to keep in mind in which interval we'll have to establish the continuity. And the second part of this problem is, are there any critical points where this function undergoes a transformation, right? So looks like I need to be worried about 2 points, right? One is 0, uh, and the other point is pi by 4, right? So for the open interval 0 to pi by 4, which is my part 1, right? 0 to pi by 4, and I'm going to call it my open interval x belonging to 0 to pi by 4. And let's write that open interval 0, comma pi by 4, right? Pi by 4. What is my function? My f of x is a simple sin x, right? And we know that sin x is continuous, right? So is continuous, right? And similarly, I do my part 2, which is my open interval pi by 4 to pi by 2, right? Where this function f of x takes the value cos x, right? And we know that cos x is a continuous function, and in this particular interval, we do not have a challenge, right? So I have established my continuity in the open interval 0 to pi by 4, and then in the interval pi by 4 to pi by 2, right? Open interval pi by 4 to pi by 2. So I have 2 points left to examine the continuity at. So unlike my previous videos where we had 3 parts, this problem we'll have 4 parts to it, right? So x, we'll pick up the easier one first. X equals pi by 4, right? And let's work out the continuity. F of x equals pi by 4. And what is that? We know that when x equals pi by 4, I go back. I know that I will have to use this particular equation, which is my sine of pi by 4. And what is that? which is my sine of pi by 4, which is 1 by root 2, right? So let me 1, sorry, 1 by 2. And then I have my LHL, which is x equals pi by 4 plus, right? X equals pi by 4 plus. And what is that? Which is where I will have to pick out the limits, right? So x greater than pi by 4, this function takes a value cos x, right? So let's pull that out. And what is my cos x, which is nothing but cos of pi by 4. Let's write it like this: limit extending to pi by 4 plus, means I'm approaching it from the right hand side, right, which is my cos x, which means I have a cos of pi by 4 plus h, which is cos pi by 4 plus h, which is again h being infinitesimal. I'm left with a cos pi by 4, which means what is my cos pi by 4 is cos 45 degrees, which is again 1 by root 2, right? And RHL is, let's move to the next step, and we will have to, I'm sorry, this was my RHL, and this is going to be my LHL. I'm sorry, folks. So I have my f of x pi by 4 minus, right? And for values lesser than pi by 4, I know that my function is taking sine x, right? So that's because of this particular equation. So when x lesser than pi by 4, I have my f of x equals sine x. So I picked this up and I'm going to rewrite this. I'm going to copy this, but you're going to watch me change this as I go about. Sine of x, and I have it as sine of pi by 4 minus h. And I further establish that my LHL is also sine of pi by 4, h being infinitesimal and small, and I have it as 1 by root 2. So what do? I pick out my pen and I say that my f of x equals pi by 4 is 1 by root 2. The limits are equal, the LHL and the RHL are equal, which means that I can comfortably say that the limit exists. And my next condition is my limit that I calculated has to be equal to x equals f of x equals pi by 4, right? And what is that? That is also equal to 1 by root 2. So I have all the conditions fulfilled for continuity at x equals pi by 4. So the function at the critical point, okay, is continuous at x equals pi by 4, right? And then I go to my part 4, which is we still remember that we have an x equals 0, right? So this function starts from x equal to 0, right? And it does not have a definition at x lesser than 0, right? So we really don't have to worry about the worry about what is at lesser than zero, because that is outside the interval of where x belongs to, as far as this particular function is concerned, right? I hope you folks are with me. So the function f of x is defined starting from x equals 0, right? And at x equals 0, can we still call this function as continuous? The answer is yes, the function is continuous, because in this particular case, we will have to be worried only about the right hand limit, because the function starts from 0 and proceeds till pi by 4. At pi by 4, it undergoes a transformation from sin x to cos x and takes a value cos x for all values greater than pi by 4, right? So we don't have to really be worried about x lesser than 0. As far as this function is continuous, this function starts from 0, right? So we will have to be worried only about our RHL, where f of x equals 0 plus, right? And what is that? It is my sine of 0 plus h, which is nothing but my sine of 0, which is 0, right? And what is it at x equals 0? It is again my sine 0. I don't have to worry about it. So it is my 0, right? So apologies, folks. I think we'll have to call this out as limits. So we will again pull out our pen now. So, like I established earlier, why we don't have to worry about LHL in this case, because the function is defined in the interval, closed interval 0, open interval pi by 2, right? I mean, it is defined in the interval 0 to pi by 2. Let me repeat it. It includes 0 but does not include pi by 2, right? And that is why we discussed that very much in the beginning, right? So I'm just going to highlight this part where we mentioned the interval where continuity is to be examined is closed interval 0 to pi by 2 open interval, right? So I know that my function is continuous at all the points where continuity was to be examined, right? And we have established that function is continuous at x belonging to, right, belonging to 0 comma pi by 2, where 0 is included and pi by 2 is not included, right? So hope folks, I hope you found this content useful. Please do subscribe to my channel and support. Thank you.